Hello class, this is Mr. Roberts and we're going to look at the homework now for section 2.3.2. Happy to be here, happy to help you step through any one of these problems that you maybe needed a little bit of help with. Remember, my suggestion is always that you don't sit and just watch all these all the time. But certainly, if you're stuck on a problem, a good thing to do is to just scan the QR code and kind of take a look at one you might be a little bit confused with. So for this problem, I can see that I have multiple points given, and I notice that these points are not, the differences in x's are not just one, right? They're all over the place. So what I'm going to do is I'm setting out to figure out what the slope of this line is, and I need to look at a couple ratios, right? I need to look at the change in y, and I'm going to divide that by the change in x to figure out one of the two parameters I need to define a line, right? I need both the slope parameter and the y-intercept parameter. Remember, we can write the equation of a linear relationship in the form y equals mx plus b. Two of those things are variables. X is a variable, y is a variable. In order to describe a particular line, we need to know what the two parameters are. We need to know the slope parameter and we need to know the y-intercept parameter. So I'm not given the slope parameter today, but I can find it certainly by using some points. And I'm going to go ahead and say, let's consider this xy pair going to this xy pair. So I've got a direction here. So my change in y is at 44, and I'm going to subtract from that 30. And if I take the 44 units that y ends up at and I subtract 30 from it, you know that we're going to get a value of exactly, what, 14? No, we're going to get a value of 44 minus 30, exactly 13. No, exactly 14. And I'll write that right here. So this is my change in y. Y goes up by 14 units. If I'm starting at 30, I would jump up by 14 units to get to 44. And if I look at my x values, I see x ends up at 5 and it begins at 3. So my change in x increased by 2 units. So I can reduce this, right? My slope ratio as a unit ratio is 7. I go up 7 units y for every 1 unit increase in x. Now, what's important to understand is that I could have picked any of these points because they're all on the same line. Any two points are going to produce the exact same slope. And I know that seems maybe not entirely intuitive, but to show that, I'm just going to pick another 2 points. I'm going to pick these 2 points this time, quite arbitrarily. And this time I'm going to say I begin at this point and I'm moving this direction, right? This direction. So if I'm looking at that, I'm going to say that for y's, again, I'm doing my same ratio, delta y over delta x. I'm saying that my y value ends up at 2 and began at 30. So I've got 2 minus 30. And for x's, I see that x ends up at negative 1, but it began at negative 3. It began at positive 3. So I'm taking negative 1 and I'm subtracting 3. And my numerator, 2 minus 30, gives me this value of negative 28. And in my denominator, I've got this negative 1 minus 3, which is negative 4. And yeah, sure enough, if I take negative 28 and I divide it by negative 4, I get exactly positive 7. So it doesn't matter where I go. It doesn't even matter the direction I go. I'm always going to get that my slope parameter is the number 7. So I know one of my two parameters to describe this line. I know the slope parameter, m, is 7. But I don't know the y-intercept. And it's completely arbitrary which point I pick. If I'm told all these points are collinear, I could pick any one of those xy pairs and I'm going to get the exact same y-intercept. I think for simplicity, I'm going to go ahead and pick this one. I'm going to say, let's pick the point when x is 1 and y is 16. So what I do is I'm going to go ahead and write down y, which is 16, right? My y I'm replacing with 16. My slope parameter I figured out was the number 7. The value of y for this point that I've selected is 1. I'm sorry, the value of x is 1. And then I've got my plus b. So this becomes 16 equals 7 plus b. If I take away 16, or 7 rather, from both sides, I get that 11 is b. So my other parameter Y-intercept is 11. And it's kind of fun. It might be nice for you to pick a couple other points and convince yourself that yeah, it completely doesn't matter which one of those points I select. I'm going to get the exact same value of b. So let's write the equation of the line. My line is y equals slope parameter 7 times not times m. That was my slope parameter. 7 times x and then plus the number 11. And again, if I pick any one of those points, for example, if I picked 5, 5 times 7 is 35. 5 times 7 is 35. Why does that not seem like it's working? 7 times 5 is 35. 35 plus 11 is 46. I have the wrong number. Oh, I know why I have the wrong number. Oh, I'm so glad you didn't leave. It turns out that 16 minus 7 is not 11, right? So let's come back to here. On each side of this equation, on one, I messed up. On one side, I subtracted only 5, and on the other side, I subtracted 7. Hey, if you have equal things and you subtract equal things, you get equal things. But certainly if you subtract 5 on one side and 7 on the other, you don't get equal quantities. So I'm going to take 16 and I'm going to subtract 7 from that and I'll get 9. And I'll take 7 plus b and subtract 7 from that and I get b. So I can see my y-intercept parameter was actually 9. And you know, this kind of illustrates an important idea. Even though I was pretty confident I had the right stuff, by me just taking a moment to plug in 5 and confirming whether or not it gave me 44 really helped me catch that error. Now I can go ahead and say if I put in 3, I should get 33 times 7 is indeed 21, and 21 plus 9 is 30. Let me check the 5 now too, right? 5 times 7 is 35, and if I take 35 and I add 11 to that, no, I just said add 11 to it. We've already had this conversation. I'm adding 9 to it, and I do indeed get 44. So, wow. It's only 2:54. It's not even nap time yet. Okay, let's move on to question 103. This problem is something that we're calling checkpoint number 2, and it really is related to 8th grade curriculum. If you do look in the very back of your textbook, back sections back there, you will find these checkpoints. And not only do they have some additional information for these, but they have multiple practice problems related to these and all the answers as well. So if you feel like you're uncomfortable with anything you see here, please check those out. In fact, I believe ideally at this point you are comfortable working with these types of problems and can solve them correctly. If you feel you need more confidence when solving these types of problems, then review checkpoint 2 materials and try the practice problems provided. From this point on, you'll be expected to do these problems correctly and with some confidence. So let's go ahead and take a look. Yeah, after that thing I just did, let's see if I can do these correctly or with confidence. I have confidence, but am I correct? So I've got values for my variables, right? I'm told what x is, I'm told what y is, and I'm told what z is. Probably the thing I want to be most careful of is like on part C here, when I'm squaring a negative value, I want to make sure I'm using parentheses and capturing that correctly. Maybe another error would be like for D, I'm subtracting y, and y is negative, so I'd be subtracting a negative 3, which would be adding 3. So be aware of those things. I'll just do 2 of these. Let's look at A and then the last one, E. And I'm pretty sure the answers are all provided for these online because they're checkpoints and they want you to check them. So A, we've got 2 times x. Playing the part of x is the number negative 2, plus 3 times y. Y, it says up there, is negative 3. And then finally we're going to add to that z, which is the number 5. 2 times negative 2 would be a negative 4. And then plus 3 times negative 3 would be minus 9. And then plus 5. If I combine, because it doesn't matter, if I combine the negative 9 and the 5, I would get negative 4. And negative 4 minus 4 would be negative 8. So I'm pretty sure this is negative 8. Let's go ahead and do E as well. So on E, man, I could do all these. This is, if you don't see the answers to these online, I'm pretty sure they're all posted on the CPM homework help. Come talk to me because it's definitely worth checking to make sure you get all of these right. And just flip to the back of the book too. Look at the checkpoint materials back there. So let's do E. E says it's the opposite of Z squared. So I've got a negative that's outside, and then here is a place to hold Z. Z is a positive 5. I'm going to square that. Then I'm going to multiply that result by 1 minus 2 times x, where x is a negative 2. And then we're going to divide that entire thing by y minus x. Y is negative 3, and I'm going to subtract from that x, and x is negative 2. Okay, so let's take a look at the numerator. I'm going to evaluate these parentheses first. I've got a 1 minus 2 times negative 2, which is going to be 1 plus 4, right? 1 plus 4 is 5. So this is going to be, I'm just going to rewrite the opposite of 5 squared times 5 divided by, let's see, negative 3 minus negative 2 would be negative 3 plus 2, which would just be negative 1 in my denominator. So now 5 squared is 25, and 25 times 25 is 125. So I have in the numerator the opposite of 125, and in my denominator I've got a negative 1. So if I would evaluate that, that should give me positive 125. So I do recommend going over those very carefully and checking all of your answers. And then if you feel like you need more practice to be confident and competent with those, please refer to the checkpoint materials at the back of the book. Question 104. It says, if you are traveling at a speed of 50 miles per hour, how many feet per second is this? Show your work using Giant 1. So we're given a rate of 50 miles, M-I-L-E-S, per hour. And we want to express the same speed in different units. We want the units to be feet per second. So a couple giant ones that I know, I guess we'll handle time first. I want to get time to be seconds down in the denominator. So I'm going to put hours up in the numerator. And I'm going to put, I'm going to go to minutes first. 1 hour is 60 minutes. M-I-N-U-T-E-S. That is definitely, those are equivalent amounts of time, so that's a giant 1. I can multiply that by 1 minute is clearly the same as 60 seconds. So if I look at the dimensional analysis, right, if I look at my units here, you can see I've got hours forming a giant 1 with those units hours. And I can see I've got the minutes here forming a giant 1 with the minutes. And I'm just looking at the units, not the numbers. So at this point, I'm looking at miles per second. Miles per second. And you can see to get that, I'm going to have to take the 50 and divide it by 60 and divide by 60 again, right? 50 over 60 squared. So I'm not done though. I need to get feet, and it seems to be a giant 1 that most of you seem to generally know, and I'm not sure exactly where that comes from. But we got to thank some local area teacher really kind of drilling this into most of you. The fact that 1 mile is 5,280 feet. So I want the miles to go away. So I'm going to put miles in my denominator. So I'm going to say 1 mile. And in my numerator, I'm going to say that's 5,280 feet. And those are equivalent distances, right? They're the same length. So that really is the number 1. The beauty of this number 1 is now you can see I've got miles in the denominator here, and I've got miles in this numerator. So now the only units that are remaining for this entire problem is you can see I've got seconds and I've got feet. So this answer will be feet per second. Now it's just a matter of doing the arithmetic. The arithmetic we need to do is in the numerator we need to calculate 50 times 5280. And in my denominator I need to figure out what 60 times 60 is. And my units will now be feet per second. So let's go ahead and grab that. I'm going to grab a calculator, go 50 times 5280. 50 times 5280 is 264,000. Yeah. And on my denominator, 60 times 60 is not 360. 60 times 60 is 3,600. Yeah. 3,600. So I'm going to take the 264,000 and I'm going to divide that by 3,600. And when I do, I get 73. I get 70. Well, I get 73 and a third, right? 73 and 1/3, not 1/2, and a third feet per second. And we could write that as a decimal, right? 73.3 feet per second. So we had our speed 50 miles per hour, and apparently that's the same as 73 and a third feet per second. You know what? I can check this with your favorite personal assistant. So fire up Siri. Hey Cortana, whoops, wrong button. Convert 50 miles per hour. That was not very efficient. I did a terrible job. Convert 50 miles per hour into feet per second.
50 miles per hour is approximately 73.33 feet per second.
That's great. 73.33 feet per second. Fabulous. That's nice that we can check that. Okay, let's move on to question 105. And it looks like it's the last one, 105. So Tim, mathletes, I like mathletes. Tim is buying snacks for the mathletes who love microwave popcorn. Of course they do. Tim looks at the popcorn selection. He notices many brands and different prices. He wonders if the cost is related to the quality of the popcorn. To answer his question, he purchases a random sample of popcorn bags and records their price. When it is time for the mathletes meeting, he pops each bag in the same microwave, opens the bag, and he counts the number of unpopped kernels. Okay, so we've got here price and unpopped kernels. Make a scatter plot on graph paper and draw the line of best fit. Choose 2 points on your drawn line and use them to determine the equation of the line of best fit. What do the slope and y-intercept represent in your equation? And then finally it says estimate the number of unpopped kernels after cooking in a bag that cost $1.19. So let's go ahead and set up a nice graph paper and get these values on there. So I set my graph up like this. My unpopped kernels on the y-axis are counting by 5, and every 4 units on my x-axis is $1. So each one's is 25 cents. So let's go ahead and plot these points now. So when I'm done, these are the points I have, and if I'm trying to approximate a line of fit, I can bring my ruler over here, and honestly, I'm going to actually use those 2 points. Your line of fit doesn't have to go through points that are in your data set. I just think those 2 are a legitimate descriptor of the data, so I'm just going to draw the line through them. And with that, I can use those XY points to figure out the equation of the line. So now that I've got 2 points, I need to remind myself what these were. One of them was a bag that cost $2.30. That's this one. So this was $2.30, and it had only 4 unpopped kernels. And the other bag had it was cheap. This was the 60 cents one. This bag cost 60 cents, so 0.60, and it had 30 unpopped kernels. So now that I've identified those 2 points, I'm going to go ahead and figure out the equation of the line that goes through those points. So for convenience, I just transcribed those points over off to the side here. So you can see I've got 60 cents had 30 unpopped kernels, $2.30 had 4 unpopped kernels. So if I'm going to find the equation line that goes through those, I'm going to begin by figuring out my change in y and my change in x. So I'm going to go ahead and look at those y's. I'm going to say just arbitrarily that I'm going this direction. So I end up at 4 for y, and I began at 30. So 4 minus 30 is my change in y. For x, I end up at 2.30, $2.30, and I began at 60 cents. So I'm going to take the 2.30 and subtract 60 cents, 0.60. And I'm going to grab my friend. So the 4 minus 30, of course, is the obvious one. It's 20. I'm typing the answer as I say the problem. It's negative 4 minus 30 is negative 26. So y decreased by 26. And while it was doing that, X ended up at $2.30, but it began at 60 cents. So 230 minus 60, nope, minus 60 cents gives me $1.70. So the cost went up by $1.70. 26 negative divided by $1.70 gives me a rate of about negative 15 point, I'll round it to 3, 15.3. So what this is telling me is that as the price increased, as if I was to express this as a unit rate, as the cost goes up by a penny, no, these were dollars, right? As the cost goes up by $1, the number of unpopped corns decreases by 15.3. So the more you pay, the less likely you are to have unpopped kernels. So it's one of 2 parameters we need, right? That's my slope parameter. But in order to come up with the equation of the line, we also need our y-intercept parameter. So to figure that out, I'm going to use the slope-intercept form. That's what we've been doing a lot lately. Y equals mx plus b. And arbitrarily, we'll just pick one of these 2 points. I'm going to pick the point where y is 4. This y is 4. And then I've got the negative 15.3 times x, which is $2.30, and then plus some b, my y-intercept parameter I don't know. When I look at the graph, I can see that it's close to 40 unpopped kernels, so I'm looking for something around 40. So I'm going to go negative 15.3 times $2.30 gives me negative 35.19, and that equals a positive 4. So I'm going to add 35.9 to both sides of that. So 4 plus 35.19. Whoops. 4 plus 35.19 is, 39.19. 39.19 is B. So now we've got both of our parameters, right? We have both our slope parameter and our y-intercept parameter, and it is close to 40, right? It's about 39.19. So the equation that I have is y is equal to negative 15.3x and then plus 39.19. So it's like saying, hey, if you got a bag of free popcorn, if you got a bag of popcorn that costs nothing, you can expect 40 of the kernels to be unpopped. Of course, popcorn's not free. I don't know. The other thing is that this answer is completely arbitrary, right? It just depends on the 2 points I picked. I think the line that I chose was reasonable, and I think that there could be other lines, certainly for sure. What I'm looking at is that you guys should have definitely a slope that's negative, right? And it should be somewhere in this neighborhood. It's decreasing as the cost of the popcorn goes up, the number of unpopped kernels decreases, and also you should have a slope somewhere reasonably around 40. But there's a lot of variation in that, and I probably, considering the inputs to this, it's probably not very wise to have these decimals. So maybe negative 15x plus 39. That's probably a more reasonable answer given the inputs that I have here. All right, finally, let's move on to our last question for this problem set. It says, use what you know about y equals mx plus b to graph each of the following equations quickly and on the same set of axes. Okay, so here's a reasonable set of axes, and the first problem I have has a y-intercept at, and I guess I'll do these in different colors. I'll do this one in this red. So it has a y-intercept at 5, so I'll put a small dot at 5, and it has this slope pattern of up 3 units, 1, 2, 3, 5, 6, 7, 8, and then over 1. And I'll repeat that up 1, 2, 3 over 1. So with that, I can grab my ruler, line it up so that it's going through all those points, and then I'll just quickly draw that line. So that's my first line. Next one we'll do in this beautiful green, and its y is negative 2x plus 10. So my y-intercept's way up here at 10, and I'm going to go down 2 units and to the right one. Oh, there's a point they share in common, although my red line's off a bit. Down 2 over 1, down 2 over 1. So there are those. Line up my ruler, and with that lined up really well, I can just quickly draw that line that goes through it. And then the last one I have is y is equal to 1.5x. I'm going to rewrite that. I'm going to say y is equal to 3/2 x. It's easier for me to do the slope pattern with that fraction. And my y-intercept actually is 0 for that because there's no plus. You could say plus 0. So I'm going through the origin, and then from that point, going through the origin, and from that point I'm going to go up 3 units into the right 2. So up 1, 2, 3 over 2. And I'll do it again, up 1, 2, 3 over 1, 2. And with those points, then I'll line up my straight edge, and I'll just rapidly do this as quick as you can. Well, there we go. So you can see, having equations written in slope-intercept form does definitely facilitate graphing them fairly quickly if you can identify the proper y-intercept and the slope. That's it for those problems. We've finished at question 106. I'll see you guys in class.